Okay, you can try to use the presence code in the chat box. And I have a good news. Yeah, good news for you that maybe this class will be finished. Yeah, will be over at around 8 or 8:50, 8:10. Yeah, maybe 8 o'clock, around 8 o'clock. It will be end. It will finish in at the 8 o'clock. That will be good news for you, maybe. Yeah. So then let we start. I just realized that the problems that I already given to you last week is only covering spur gears. Yeah, no, so without any problems with for helical gears. So, but that's okay. So let's we discuss again about the spur gears. Because last week I think there is still so many problems that we can discuss it together, particularly about the strength of the spur gears. Yeah, how to design the spur gears, how to find the appropriate phase width of the spur gear, how to determine the rate power of the spur gears, how to considering the ACMA bending and also ACMA wear. So, and there's still a lot of problems that we can discuss about the spur gears. So please, if there's any one of you wanted to explain it, raise your hand or unmute your microphone, and then let's we discuss it. Yeah, last week we have 1, 2, 3, 4, 5, 6, 7, 8 students. Yeah, asked questions, and three of 8 asked the questions, and also and five students explain some problems. Yeah, explain the answer of some problems. So then I think we still have so many problems. Yeah, there is 1, 2, 3, 4, 5. Oh, there's a lot of problems. I already give it to you last week. From the simple one up to the complex one. Yeah. Okay. Now maybe if you want to discuss about 1425, that's okay, because last week one of you already present the solution for 1424, right? How to find the power 1424. Then if today we discuss about 1425, that will be good.
Excuse me, sir.
Yes.
I want to explain for 1425.
Oh, okay. Please, Mas William.
Can I have the
Yeah.
screen share alone?
Yes. Yeah. I already give it.
Sir. Okay. Now I will explain about the solution for 1425. The problem is the speed reducer from problem 1424 is to be used for an application requiring 40 HP and 1145 revolution per minute. So we have to find the safety factor by the ACMA factor of safety uh, for the bending and the wear. So here,
Sorry, Mas William.
yeah,
Last time we already find the rate power, right?
yeah,
Around how much
uh,
the S power? Around 50, I think, yeah. Around 50 or 60. The answer from 1424.
50.
50 something, yeah. 50
Yes,
something, right? Okay, so 50 something H power. But
yes,
now for these problems, the power only 40 horsepower. So the answer should be the safety factor should be higher than one, yeah. Should be, yeah.
yes.
Okay. Okay, please continue, Mas
Okay.
William.
So because this is from problem 1424, the transmitted load is already known, sir, from the previous calculation. So we can use it to find the safety of factor. So before of it, uh, the formula for transmitted load is like this: the 1335, and there's we need the overload factor k 0 here because for the safety factor uh, for the material we need the overload factor so it can be safe for the tangential for the yeah transmitted
Uh,
load. I mean,
Mas William, sorry. Could
yes.
you show to us which equations that that we will use in order to find the safety factor? I mean the final equations with including the safety factors parameters, variables. Which one?
Like this, sir?
Yeah. Oh, like this one. Okay. So in order to find the safety factor, we need to find the force. Yeah, Mas, yeah.
Yes, we need to find the transmitted load
Load.
first.
What
And
what is the difference between W1T and WT?
oh yes, so the WT is a calculation from here, sir. So we first calculate about the allowable load.
Okay, a level load
Yes.
WT.
So
Oh,
yeah, I explain this
okay.
where it's come from.
Hmm.
We need the overload factor K now
Okay.
because this is said in is mentioned on the
Hmm.
problem that the load is moderate shock.
Hmm.
So the K now is 1.25 here.
Okay.
So the overload factor is depends on the load, sir,
Okay.
given on the gear. So this is the allowable load from the calculation where the power is 40 HP and the velocity is P times D times omega per 12. This is the conversion to feet and the feet to inch, and then the diameter is come from the before problem, previous problem. The diameter is 5.5. So here's come the safety factor formula for the bending. Uh, because we already know the transmitted load, so we just need to divide it and find the safety factor here. And this is for the wear.
Oh, okay. How about the
So
W1? W1T it's coming from the previous problem also, yeah.
Yes, sir.
W1T.
It's already known from the previous.
Wait. W1T is coming from from phase width, yeah. It's coming from the geometry, yeah. It's coming from the geometry of the spur gear, yeah, Mas William, yeah.
Yes, sir. From the wait.
From the geometry, right? Because we have materials, geometry, yeah,
Yes.
and also geometry. It means phase width,
Yes, sir.
diameter.
Yeah.
Without any horsepower, yeah. Without any horsepower, yeah. It's
Without,
only
yes.
coming from the materials of spur gears, some parameters, some factors, and also diameter, phase width. Then we can calculate the F, yeah. The W, the load, yeah.
Transmitted load, sir.
Transmitted load. Okay, that's the transmitted load that happen in the spur gear. Okay, so then W1 is coming from the horsepower that wanted to be delivered by the spur gear, yeah. W1 only, yeah.
Yes, sir.
From the problem, right? Yeah.
Yes, the allowable load, sir.
You say that that is a allowable load, yeah.
Yeah.
You said it allowable load. Okay. Let me think. Safety factor should be equal to W per allowable. Allowable is coming from the materials. Okay. Is it correct? Yeah? Is it correct? Okay.
I check it with the solution manual and it's already correct.
Okay.
Sir. I think.
Okay. Let me. Okay. So now let me see the results, the final results. What is the difference between safety factor because of the bending, and what is the difference with wear, the safety factor?
So here we have to examining the factor of safety, identify the threat to each gear and to the mesh.
Okay, that's
so good. Here I identify the threat, and in the books it mentioned that if we have to calculate the safety factor and compare.
I think what's the difference safety S? What is the difference SF and SH?
SF is the bending, sir.
Oh, SH
is the wear.
Oh, wear. Oh, okay.
Yeah.
And so P one is opinion and one is another one is G, right? P and G,
Yes,
right?
sir.
Not P and P.
P and P.
I mean here in your.
This is FP and HP. Oh yeah.
Another one,
yes,
yeah.
sir.
This one PG and G, yeah. Pinion and gear. Okay. Should be SH. That's okay. SH, I think. Oh, wait. F is bending, yeah. So should be your second S should be F.
Yes. So this is the result, and from here we can compare that the.
No, Mas William. I think the first one 3.15 SFP. That's correct. The second one 3.86 should be SFG. In my opinion, bending.
Oh yeah, gear, yes, sir.
Bending in gear.
So this H for P.
Yeah.
Okay. Okay, so this is the final result from the calculation that the thread is from pinion wear, because here the safety factor is very
lowest one, yeah.
Yeah, the lowest one.
Mm.
So this is the formula. This is the formula
Okay.
which used before, sir.
Okay. Okay. Please go back to slide number 9. Okay. And how about the if we compare between the bending and wear, which one is the most critical, more critical?
Uh, I from the book I read that we need to power to oh to square it, sir, from the wear.
The wear,
If we want to compare it with the
the bending,
bending.
we need to make it square.
Yes.
Square, it means multiply by itself. Yeah.
Yeah. So from previous calculation, it it is the true value is 1.03 and
Okay.
1.09, but the square value is 1.06 and
1.8.
1.18.
Uh-uh.
So I use the square. This is the square, sir,
Oh,
because I compared it with the bending.
okay. Even though we square it, the safety factor, but the value still
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 small.
lower than
Yeah.
bending, right? So
Yes, sir.
it means wear is more dangerous than the bending.
Yes, sir.
Yeah. Okay. 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 So that then it's also match. Yeah. It's also confirm the previous solutions for 1424 when we calculating the horsepower. Yeah, the horsepower
Yes.
based on the geometry and materials of spur gears, we calculating the horsepower. Then in this calculation, in those results, last week, I mean, we can find that the horsepower for bending is greater than horsepower from wear.
Where?
Yeah, then it is why we determine the rate power from the wear.
Yes.
Yeah, because the wear is more dangerous, more critical
Yes.
than the bending. And from your solution today, we also see the similar results. Yeah, that the safety factor of wear is lower than safety factor of bending. So it means that wear is more dangerous than the bending. Okay.
Yes.
Okay. And how about the pinion and gear? Is it always the pinion more critical than the gear or not, or it's depend on the problems? Because in your results, the the most critical one is the pinion. Yeah, wear. Okay, we already agree with that. How about the pinion? Is it always pinion, or sometimes it can be happen to the gear? How is
Mm,
your how is your opinion, Mas William?
wait. Um, 30 F G F G. It's the geometry and the face width uh makes the pinion always lower, sir.
Yeah. Actually, it's depend on the geometry and materials. Yeah.
Yes.
Usually, we use when we have a pair of gear, we use a same materials for pinion and also same materials for gear. Is it correct, right? But
Yes.
sometimes we can use the different materials or same materials but different face width. Yeah. So I think, in my opinion, is it not always happen to the pinion wear? Yeah, the critical one. It's not always happen in the pinion wear. Sometimes it can be happen to the gear. It's depend on
That's
the
right.
geometry, I think, the phase width, because sometimes we use the same phase width, sometimes we use a different phase width. That's I think that's okay, as long as we have the reasonable, yeah, reasonable reason, that it will be okay. Rational reason, that will be okay. Okay, so then it can be happen in the pinion and also can be happen in the gear, yeah, Mas William, yeah. So you
Yes,
need
sir.
to calculate it first. Okay,
Oh, yes,
but
sir.
for wear and bending, normally it's happen in the
Where?
dangerous one is a wear. Okay, okay, that's very good, Mas William. Is
Yes.
there any questions from other students?
Sir, I want to ask about something, sir.
Yeah, please, Mas Edgar.
Okay, sir. I still confused that can we use load for safety factor, sir? Because when we see at the book, we usually use the stress.
Mhm.
Yes, sir.
So
Uh,
sorry. What is the question? Sorry, I'm
uh, can we use the load as the safety factor, sir?
load as the safety factor.
Factor.
Oh, I know. Usually we use safety factor is some
Stress.
stress divided by some stress. Yeah, another
Yeah.
stress. Yeah, but in these problems we use the some loads divided by another load. Yeah.
Yeah.
Okay. Actually, this load is also coming from the safety from the stress. Actually, yeah, like you see here in this slide. Yeah, in this Mas Williams slides, we see that this WT is actually coming the set stress equal to something. Gear bending stress equations. It's a stress equal to something, right? It's actually it will be same, Mas Edgar. If you want to find the omega, sorry, what's that? Omega, gamma, what is this? Sigma, right? Yeah,
Sigma.
stress first, and then after you find the stress by input some data, the factors, the geometry, also the load, yeah, and then you use that stress information, that stress value, into your safety factor equation. I think the results should be also same, yeah, because the stress is coming from the load. Stress equal to load divided by for the average shear stress should be divided by only area. Yeah, but when we considering the bending, the stress equal to load times distance from the neutral axis to the point of interest divided by the moment of inertia. And if we just delete the the area, or I mean the surface, yeah, the geometry of the surface, then our stress is straight to the is equal to load. Then so in my opinion it will be okay, Mas Edgar. You can use load, or you can use stress.
Oh, okay, sir. I get it. Thank you, sir.
Okay.
Oh, yes, sir. Can I ask another question, sir?
Okay.
I still didn't get about the where is more danger than bending, sir.
Why?
I didn't get about your apa namanya your interpretation before,
My
sir.
interpretation, yeah,
Yeah,
my conclusions
yeah.
coming from the value, Mas Edgar.
Oh,
The
the
value here. The
oh
value
the
here.
before, yeah.
You see that safety factor is safety factor because of where.
Yeah.
It means from where, yeah. It's less than, lower than safety factor from the bending. Safety factor so about the how much safe the gear, right?
Oh,
Safety
yeah,
factors.
yeah, yeah, sir.
because they have a small value, then it means more dangerous.
Mhm.
It's for in other side, for the pending, the safety factor value is higher than 3 point something, higher than 1 point something, 3 point something. It means more safer, more safer. So then not critical, not dangerous.
Oh, okay, sir. I get it. Thank you very much, sir.
Okay, welcome.
Sir, excuse me, sir. I want to ask something.
Yeah, Mas Sultan.
Uh, First of all, William, could you scroll up to calculation of WT?
Okay, wait. The allowable load.
Yep, the level.
Okay.
Here I'm really confused, sir, about the calculation about WT because there is some KO there, and when I read the book, read Sigley, there is no KO, sir. But KO is but KO will put when we try to calculate the stress. But in allowable load, we uh, I don't I didn't see if WT should times by KO, sir. So
Oh, okay.
why William times KO here?
Okay.
I still didn't get it.
Let we discuss it in two ways. Yeah. The first way, Mas William showed to us which equations that including the KO. Yeah, that's the the first discussion, and the second discussions was the effect of the KO in the WT. I mean, with KO, then the value will be higher, or without KO, the value will be lower. That's the another discussion. So please, Mas William, you please explain it to us, which the source of, what is the source of your equation?
Okay, sir. So I will explain it here. I pick from the equation 13 and 35, where this is we calculate the transmitted load. But because we want to find the allowable load, it means that we have to times it with the sum factor, which connect to the overload factor. Why in here in this calculation I calculated with the overload factor, because the overload factor is some factor which intended to make allowance for all externally applied loads. So here from the problem, the load is moderate shock. This is why this is why we must concern for the overload factor in the allowable load.
Okay, so in the textbook, yeah, which equation that include the KO? Which equation? Not this, not 1335, right? Not I think another equation, right? Another equation that include the KO. Maybe
Yes,
sigma
sir.
something, yeah. Sigma equal to something, maybe.
Yeah, sigma.
Which
Sigma
one?
equal to yeah,
This
like here,
Oh,
sir.
this one. Okay. Oh, okay, okay. I see. So, in my opinion, yeah, Mas William, Mas Sultan, this KO be should be used when we determine the stress that can be happen in the gear. Yeah, because this is the overload. I know that. So sorry. KO, KV, KS. Yeah, the many factors there with a K. It's including in the equation of sigma equal to something. So it means we have to consider it when we calculate the sigma, the stress that happen in the spool case. And we already include it, Mas William, when you determine the W1T.
Yes, sir.
Is it correct or not? Yes, right? When no, not you, but your friends last time when he calculated the W1
Oh,
W1T, he
yes.
already included the KO, of course.
Yes.
Yes, right? Okay, so then the overload factor is coming because we have the spur case. Okay, we have spur case with geometry and materials. Okay, it's spur case, and this spur case when we used it in the operation, yeah, maybe sometimes he cut the moderate shocks or heavy loads. Yeah, maybe sometimes the gears is operating at the room temperature, but maybe sometimes it's operating in higher than more room temperatures, and also another factors. So those factors, all of those factors must be included into the equations. It is why we use this equation 14, 15. Yeah, sigma equal to something. So because we already include the overload factors in the sigma equal to something, then when we considering the WT, I think we cannot use the KO in the WT equal to something. It's just using WT equal to 33,000 H divided by V. That's all, without KO, because that's the allowable, not allowable. What is allowable, right? The allowable loads is coming from not from the spool gear, but from the outside information. I mean, we want to. One operator said, "I want to use this spool gear for this horsepower, 40 horsepower. Can we use it?" So then we need to calculate the WT without KO. That's in my opinion, Mas William. And we already include the KO when we calculated the W1T.
Does it mean that from the allowable load we don't
No,
need some factor
no,
because
I don't. Yeah, no, I think no, because we already include this one in the W1T, Mas William. W1T from slide 3, slide number 3. This is from your friends, right? From the previous results, yes. Right? When we calculate the W1T, I believe that your friends already include the KO. Okay. Oh, let me move to another discussion here. What is the effect of KO, Mas William? When we use KO in the equations and without KO in the equation, what's the effect to the safety factor? Will it be higher or it will be lower, the safety factor value with and without KO?
I think it will higher, sir, because we times it with value that higher than 1. So 1.25, 1.
Because we divide with less than 1,000, yeah. No, I mean safety factor value. Value.
Yes, sir. Also,
so the will be higher also, right?
Will be
higher. No.
Smaller. This is
smaller.
Without 1.
Without KO. Without KO.
It will be smaller. Oh yeah.
Smaller, yeah. And
yes, sir.
Because in the denominator, right?
Yes, sir.
What's that? Penyebut at the bottom of the equation, right? So then it will be your safety factor will be higher, right? Yeah, will be higher. Yeah, is it correct, Mas?
Yes.
Yeah. So the safety factor will be higher. Yeah. Will be higher, and that I think that's okay. That's okay. I think without KO.
Sir, I want to ask something, sir, about KO, sir.
Yeah. What's something?
First, I want to clarify that if I don't use KO from W1T, so in WT I don't have to include KO, sir.
Either. Yeah.
Oh, okay. And the apa? So if we so this question is for safety factor, and then if I want to calculate stress, uh, is it alright to neglect the KO, sir?
Now, if we have the informations of the load conditions that we use the spur kits, then we need to include it. But if we don't have any informations about the loading conditions, yeah, then we cannot say that. I think you also can say, oh, we have a KO equal to something, yeah. That's okay, I think. But if there's an informations, yeah, like these problems, the 1424, the problem already mentioned it, right? That the condition is what's that, Mas William? Moderate, yeah, moderate shock, yeah, moderate
Yes.
shock, moderate shocks. Then we have to include the KO. But if the problems or the situation didn't mention any load conditions, you can assume by yourself. Maybe not uniform, yeah. Maybe moderate shock is okay, but or maybe medium shocks with from the power, and also medium shocks at the driven machine. That also will be okay. 1.75. I think it's depend on the conditions, yeah. When your power less than 5 horsepower, yeah, and the rotation is maybe only 1000 rpm, that it will be okay if you use uniform uniform load, only 1.0, that's okay. But if you want to deliver more than 10 horsepower, 20 horsepower with speed, rotation speed is higher than thousands rpm, then I think it will be safe for us if we assume that the load condition is moderate.
So the point is depend on the situation, yes, sir.
Yeah, of course. Yeah.
But I still confused. You say that if we want to calculate the safety factor, we don't we not must to calculate this factor, sir, last time.
Last time.
The discussion before
Oh, no. When we, in order to find the safety factors, there is two value, W1. Could you show to us, Mas William, the safety factor equation? This one.
The calculation.
This okay. This okay. W1T and WT, Mas Adim.
Okay, sir. Okay.
In W1T, we have to include the K0. But in WT, just using the equations without the K0.
Oh, wait.
W1T is coming from the previous problems last week, 1424. So you can check it when your friends solve the 1424, he or she already included the K0 or not. If not,
I already checked that the KO is included, sir.
included.
In the last.
Okay, so that's okay. So KO is already included in the W when we calculate the W1T. Okay, and today Mas William calculate the WT from the equations. How to determine the WT? The equations 14 something, yeah. Which equation, Mas? Slide number 4. Huh? This is 1335. The equations to determine the WT is without KO. So we don't need to put the KO in this equation. Just using this equation. That's all.
Okay, I see, sir. Thank you very much.
Okay, welcome. Okay, so let me explain. You can stop this, Mas William. Yeah.
Yes, sir.
Thank you.
Thank you.
Let me explain in bahasa ya, in bahasa Indonesia ya. Because I think it will be difficult also for me to explain it in bahasa Inggris. I don't think it will be have a good explanation. So I will explain it in bahasa Indonesia. Jangan terlalu risau dengan parameter-parameter itu. K0, KV, K itu jangan terlalu risau. Itu risau hanya untuk keperluan ujian, keperluan kuis. Ya. Tapi saya garansi, saya nggak akan mempermasalahkan kesalahan menentukan K0, KV, dan seterusnya itu, sehingga kemudian angkanya berubah menjadi sekian ratus atau sekian puluh, kemudian itu jadi salah. Nggak, itu nggak pernah terjadi. Saya garansi itu nggak akan terjadi. Justru yang harus kamu risaukan adalah tadi itu membanding mana yang asal dari allowable dan mana yang asalnya terjadi pada spurgirnya. Gitu. Karena nanti K0, kamu lihat K itu kan semua ada di atas itu di pembilang. K itu semakin besar angkanya itu menyebabkan tegangannya jadi semakin besar. Itu menunjukkan bahwa akma itu orangnya itu terlalu protektif, kayak orang tua kita. It's like our parents, very protective. Sebenarnya yang terjadi, tegangan yang terjadi itu nggak sebesar itu sebenarnya menurut kita. Tapi menurut orang tua kita, ya, oh kamu nanti itu kalau keluar harus apa, kalau pulang nggak boleh apa, kalau bergaul nggak boleh ini. Itu semua dia meningkatkan K0-nya ditingkatkan, KV-nya ditingkatkan sama dia. Itu akma, ya, based on their experience. Our parents also based on their experience, right? Ya. Kita nggak tahu, kita nggak punya pengalaman itu, our parents punya pengalaman itu, jadi mereka mengatakan tadi. Tapi begitu K-nya kamu hilangin, stres yang terjadi jadi kecil. Kalau stres yang terjadi jadi kecil, masukkan ke rumusnya safety factor. Safety factormu kadang juga nanti jadinya kecil, gitu. Itu yang perlu dipahami. Ya, jadi karena nanti dalam kenyataannya, ketika kamu mendesain gear, ada satu hal lagi yang harus diperhatikan selain kernel-kernel itu, yaitu surface heat treatment. Itu yang saya nggak temukan di pelajaran di textbook ini. Padahal itu dalam aplikasinya itu selalu terjadi. Setiap gear manufacturer pasti akan menanyakan, ini surface heat treatment-nya apa? Heat treatment itu dalam rangka untuk meningkatkan yang nilai di allowable-nya. Heat treatment perlakuan panas pada surface itu untuk meningkatkan wear dan meningkatkan bending strength-nya. Ya, kalau kamu ingat di pelajaran metalurgi kan ada beberapa perlakuan panas di annealing atau di apain gitu. Nah, itu dia akan meningkatkan surface strength-nya dia supaya nggak gampang fail akibat wear, akibat keausan. Itu di di ACMA, kalau kamu baca standarnya ACMA yang lebih lengkap ketimbang yang ada di textbook, itu dia menginclude tersebut. Jadi jadi yang mau saya katakan K0 dan segala macam itu untuk meningkatkan stresnya, ya, supaya stresnya itu kelihatannya itu terjadinya gede banget gitu. Sementara yang di sisi materialnya kita harus juga meningkatkan kemampuan materialnya itu dengan memasukkan unsur surface heat treatment-nya. Gitu. Nah, itu yang kamu bandingkan. Kan pelajarannya elemen mesin itu kan semua membandingkan kan tegangan yang terjadi dengan tegangan allowable-nya. Dibandingkan mana yang membuat safety factor-nya. Gitu ya. Dan hal yang kedua yang perlu dirisaukan adalah angka yang didapatkan. Terutama untuk phase width dan diameter. Kamu harus punya visual yang jelas terhadap angka yang kamu dapatkan. Misalnya kamu dapat diameter 2 inch, terus kamu dapat phase width 1 inch, itu kamu bikin donat namanya, bukan bikin spurgir. Benar nggak? Diameter 2 inch, phase width tebal 1 inch. bikin donat itu namanya. Lama-lama jadi jemblem dia nanti. Kan kamu harus punya visual yang jelas terhadap angka yang kamu dapatkan dari ACMA equation itu. Kan terkadang kan kalau soal yang kita bahas ini kan masih menentukan horsepower dan menentukan safety factor. Kadang-kadang itu horsepower-nya sudah tahu, yang ditanyakan itu phase width-nya. Materialnya suruh menentukan sendiri. Itu pelajaran di PEM seperti itu. Di perencanaan elemen mesin itu kamu disuruh menentukan berapa phase width-nya. Atau materialnya apa, phase width-nya sekian. Kamu harus punya feel itu, visual terhadap spur gearmu itu kamu harus punya. Terus menentukan diametral pitch, jumlah gigi, itu harus punya visualnya dibandingkan dengan misalnya kamu bilang, oh jumlah giginya berapa ini? 1000 misalnya gitu ya kan. Diameternya berapa? 1 in. Loh, bayangkan 1 in terus jumlah giginya 1000. Meskipun itu secara persamaan nggak ada yang salah seperti yang kita bahas tadi ini, pakai apa. Tapi kan secara visual tuh dilihat tuh ya nggak masuk akal ya kan. Masuk diameter 1 in itu 2,54 cm, terus jumlah giginya ada 1000. Tebalnya berapa? Tebalnya misalnya 1 mili misalnya gitu. Nah, ini kita bikin disket ini berarti, bikin disk ini, bikin CD namanya. Bukan bikin spur gear. Ya. Nah, dua hal itu yang perlu kamu risaukan, yang perlu kamu selalu kamu pikirkan gitu ketika kita punya permasalahan di spur gear. Jadi dengan menggunakan persamaan-persamaan pasti persamaan-persamaan yang kita miliki pasti kita harus consider itu pasti ya. Tapi analyze the results ya. Get the visual from the results. It's more important than the how to use the equations. Okay, so setiap soal saya selalu I want to see the figure, I want to see the picture ya. I want to see how you draw the spur gears. That's much more important rather than the value of your calculations and the equation from your equations. Okay. That's for the spur gear. Yeah. Let we continue. So we should continue to helical gear. Yeah. Okay. Is there any questions? So
one last question, sir.
No.
Excuse me, sir. Hello.
Yeah.
Yes, sir. One last question, sir. So, does it mean it's safer that if we want to calculate the safety factor, we use the equation of the stress? Depends.
Yeah.
Yeah. Okay.
Yeah, you also can use the stress equations.
Okay, sir. Okay, thank you, sir.
Okay. Okay, so now it's already 8 o'clock. Yeah. Wait. Okay, so I'm so sorry to say about this one. I will finish this class, yeah. But you can study by yourself. I will send some helical problems to Mbak Vivi after this Zoom meeting end. Yeah, after I will send some helical gears problems, yeah, to Mbak Vivi, and maybe you can use this time until 9:30 by study by yourself. But actually it's up to you. Yeah, you can study it by yourself. You can study it with your friends, or you just leave and get to your bed again. That's actually up to you. That's okay. But I'm so sorry to say that I will end this class right now. So before I finish this class, is there another questions related to the class or to the problems? Oh yeah, one more thing. Next week, but you 2019. So semester 5, yeah. Right now you already semester 5, right? Yeah, semester 5. So because next week in our department in ITS, have a plan to do the hybrid class. So a few students, particularly from Surabaya area, have to come to the department and meet with another friends. Yeah, but maybe the teacher is still at the home like me today. Yeah, so the student coming to the campus and the teacher still at the home. That's hybrid also, right? That's also hybrid, I think. But that's only for semester 1 and semester 2, semester 3, semester 1 and semester 3. I don't know about for semester 5. If there's any next announcement or maybe next consideration from department, I also will tell to Mbak Vivi. Okay, that's all for today. Thank you very much. Keep safe, keep healthy, and keep happy. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much,
Yes,
sir.
sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.